Alright everyone, welcome back to the day 45 for daily leetcode challenge, and today we have got product of last k numbers. So in this question, again this is kind of a design question, and in this question what we need to do is we need to create a data structure such that it accepts a stream of numbers. It accepts a stream of numbers in it. Let's say this is our data structure right here, and it accepts a stream of numbers, and in the end what we need to do is we always need to return the product of the last k numbers in this stream at a given point. So let's say at a given point I have 10 numbers in this data structure right here, which is a list. We'll be declaring a list, and if it has 10 numbers at a given time, so value of k could be 2 or 3. That would mean that you need to return the product of the last 2 numbers or the last 3 numbers or the last k numbers, whatever the value of k right here is. So this is what the question is. What they want us to do is create a number container such that we can keep adding numbers in it, as like x, y, z. We can keep adding numbers in it, and at a given moment for the value of k, what we need to do is we need to return the product of the last k numbers in this list. So this is all we need to do. We need to create a stream such that we need to create a data structure such that it accepts a stream of numbers, and at a given point, for the value of k that they have provided, you need to return the product of the last k numbers. So let's say I have an array which has numbers like 10, 5, 4, 3, 2, 1, 10 and 2, and while we were adding these numbers, the the value of k turns out to be 3. Then in that case, what we need to do is return the product of the last 3 numbers, which would be 20. So this is what we need to do. Now to do that, now this could get pretty expensive if you try to kind of loop for all those k values that appears in the last k digit, in the last k values in the given container that we have. This could become quite expensive because k value could eventually be up to the length of this entire array, or it could be as short as just 1, or it could be as long as the length of the entire array that we have declared array here, and this will be gradually increasing with each time the add method will be called. Every time we are calling an add method, we are basically increasing the size of the array by adding numbers in it. So this is something which we need to kind of optimize. So in this case, what we can do is, just how we use the concept of prefix sums, we can also use the concept of prefix products. So let's try to understand how a prefix sum works. So just like how a prefix sum works is exactly how a prefix of the product will also work. So let's say that I have an array of size 5, and it has values 1, 2, 3, 4, 5, and if I ask you to find the sum of the last 2 digits or the last 3 digits, that can be quickly done. If I am asking you to find the sum of the last 3 digits, then that can be quickly done by finding the sum of all the digits at this point, and from this value right here that we got, if from this value we remove this value, which is this sum right here, sum up to this point, if from this sum we remove this sum right here, which will be 3 all the way till 15, which is all sum of all the values right here, if I subtract 3 from 15, I will be getting 12, which is nothing but the sum of these values right here. So this is how prefix sum works. In the similar manner, the prefix product will also work. If I ask you to find the product of these last 3 digits, what you need to do is find the entire product up till this point of all the values, and from this product you divide the product that we have so far for this value. So up till this value, the product will be 1 star 2 star 3 star 4 star 5. So that will be 120. So this is 120 right here, and up to this point we have the product as 2. So we need to divide now 120 by 2 in order to get the product of this remaining part, which will be 60. So this is how the prefix product is working. Instead of maintaining a count, instead of maintaining a plus, we are doing a multiplication. So what we need to do is, every time we are adding a value in this container that we will be designing, we're using this add method. What we'll do is, instead of keeping that value, what we'll do is we'll keep the product. What I mean by that is, just how in a prefix sum we use the concept of a prefix array. So in this case, to effectively find the sum up to this point, and the sum up till this point, or the product up till this point and the product of this up till this point, what we can do is we can create an array. This will be called our prefix. So let's say that we were trying to find the product, right? So we divided the product up till here, we divided the entire product that we had so far, divide this product by the product up till this point. So to eventually get the product up to a specific point, what we can do is every time we encounter a number, we keep the product. So we encountered a 1 so far, so 1 will be multiplied with nothing. So 1 which is multiplied with 1, so 1 itself. Then comes 2, 2 gets multiplied with 2, meaning the product up till the index, this one right here, is 2, and the product up till here, the product up till 0 index is 1, the product up till first index is 2. Now comes 3, 3 multiplied by 2 is 6. Now comes 4, 6 multiplied by 4 is 24. Now comes 5, 5 multiplied by 24 is 120. This is a prefix array which is nothing but the product up till each index. So 0, 1, 2, 3, 4. So if I say what is the product up till the index 3, or you can say what is the product up till the value 4, it is nothing but the value exactly at this index. We just quickly founded this. Instead of multiplying it one by one, we directly founded it, because while we were going through the values, we were maintaining an array accordingly. By each value passing, we were multiplying it with the previous value and keeping a count, keeping the value in the array. So this is how a product prefix works. So at index 3 we have the product as 24. So as we were discussing, in order to find the product of the last k or the last 3 values, if I need to find the product of the last k values, what I need to do is just how we subtracted the sum up to this point with this total sum. What we did was we divided the product up till this point, which is the total product, divided by the product up to this point, which is index 0, 1. So in that case, it will be dividing the product up to this point, which is the last index, which is 120. Divide this product by the product. We need to find the product of the last 3 index, meaning we have to exclude the product of the first 2 indexes, so 0 and 1. So the product up to the first index is 2. So we divide 120 by 2, we get 60. This means that the product of all the values at these indexes, which are 2, 3, 4, is nothing but 60. 4 into 3, 3 into 4 into 5, which is 60. So this is how the concept of prefix product will be working, and this is exactly what we'll be doing. So let's see how we can use this exact concept in this question. So it's very similar, like exactly what we discussed here. Initially we'll be starting with an empty array. This will be our container, which is empty initially. Now every time we get a value, we have to store it. Now in the previous example, we saw that let's say that this is our array, right? 1, 2, 3, 4, 5, and we are trying to find the prefix product. The first value will come as it is. It's not like it's coming as it is. It's because the initial value in the prefix sum will start with a 1. We'll start with a 1, and the very first element that we encounter, this will get multiplied with 1 itself. So it will be as it is. It could have been 2 here or 3 or any other value. This will be multiplied with the first value in this prefix array that we have. So it's a 1. So this value that we start with gets multiplied with the first element in the prefix array, which is 3. So now the new value becomes 3. Now the same thing will happen with the second element. The second element comes here. It gets multiplied with the first value in the array, which is 3. 3 into 2 is 6. So now 6 will have to add in this array. So up till this point becomes 3 into 6. Now we come here, the value that we are at currently, which is 3, gets multiplied with the first value in this array, which is 6. So that will be 18. So now it looks like 3, 6, 18. So this basically means that the product of the value up till for 0 index is 3, up till first index is 6, 3 into 2 6, and up till the third index, up till the second index I mean, is 1 into 2 into 3, is 3 into 2 into 3, which is 18. This is what this array that we are simultaneously building. Same thing will happen with 4 as well. Now the 4 comes in, it will be multiplied with the first value in the top value at the top, which is basically the -1 value. We can get this value as -1. This array -1 index. So we need to multiply 18 with 4. So that becomes 72. So now 72 will be added. So now the array up till index 0, 1, 2, 3, our prefix array will look something like this: 3, 6, 18, and then 4 got multiplied. So that's now 72. Same with 5 as well. 5 comes in, and we need to multiply 5 with 72 now. So that will look like 3, 6, 18, 5 to 360. So this is how the prefix array is forming. Now one small thing to note is that all these values are non-zero. What will happen if we again find a, if we somehow find a zero value? When a zero value appears, right, what's going to do is whatever product that we had so far will be diminished, will be turned into a zero. So up till this point we have a product as 360. The moment we reach a zero, it will be multiplied with 360 and then zero is going to be added. What this basically means is that we can forget about all the product that we had so far, because this is what the product indicates here. So whenever we come to a zero, right, what we can do is we can start from the beginning and again initialize an empty container having 1 in it, so that we don't have to deal with those extra space, because with a zero coming in we are diminishing all the products that we had so far. So whenever we encounter a zero, this is what we'll be doing. We will again reinitialize the container as this. We'll be starting with this. So when 3 appeared here, it got multiplied with 1 into 3, so 3 got appended. The moment 2 came, so 3 multiplied by 2, 6, so 3 comma 6. But the moment a 0 comes in, all these products will be diminished. So in order to do that, let's just put it as 1 and then move ahead, so that the further values which will be non-zero will be built using this value that we have. So this is what I wanted to add, an extra thing that we need to make note of, that whenever 0 appears, initially we'll be starting with this in our container. Every time we'll be getting a value, we'll be multiplying with it and maintaining this values that we are seeing. The moment a 0 appears, whatever we have so far will get diminished to a 0. So this is how the list 1 is appearing. This is how our container will be forming. Now since we have this value, which is the product of all the values in up till a particular index with each passing value, so now comes the part where we need to find the product up till the last k, meaning this part right here. So let's say that in one of the, exactly in this example, at index 0, 1, 2, 3, this is what we had so far. Up till this value we had 3, 6, 18, 360. Before 0 came in, this is what we had for 0, index 0, 1, 2, 3. 0, 1, 2, 3, right? Now let's say that somebody asks us to find the product the last k. So what you can do is get the product which is exactly at the last index, which can be easily done using the -1 index. If we take this array and put a -1 in front of it, this will give us the last value, meaning the product of all the values so far. From this product, what we need to divide is they are actually wanting us to find the product of all the k. So we need to include all these products and include all the products up till k minus 1, right? If you think about it, k is what we need, k up to k minus 1 they want us to get rid of. So what we need to do is, to get this one, we'll have to do this one, -1, and then reduce k from it, like shift this minus index by k. So from the last index, what we need to divide is to go to the actual correct index at which we will do the division. That will be done by the -1 and then shifting this -1 k by k. So what I mean by that is, let me draw it all here so that you understand better. Let's say that while we were designing our container, we went through 5 values and our container looks like this. So what this container is like, a value of all the products up till index 3, 4, 5 like that. So we started with the value 8, let's say, so or 2, let's say. So we added 2 in the list, and then 6 and then 12. That's how we are building our product prefix array. 36, like that we are building. So what this means is, product of all we had an original array in our example. The product of all the values up till 0th index is 2, up till 1st is 6, up till 2 is 12, up till 3 is 36, and up till 4 is 40. If I want to find the product of this one, which is the last k or the last 3, what I need to do is, I need to divide the product up till this point with the product up till this point, kind of split. So find the product up till this point, and then the product up till this point. So the product up till this point will be done using the -1 index, and to get the product up till this point, we need to shift this -1 by k, which will be 1, 2, 3, because k is 3 in this case. So that is why this will be a -1 divided by -1 minus k. These are the index values, and to get the actual value, we'll have to just put the list in front of it so that we get the actual product value. This indexing part, I hope you are getting it, because we are shifting with k. So that's how we are getting the last k products, by shifting this -1 with a k times, so that we divide this entire product with the product that is not needed. All this is not needed, so we divide it. Just exactly how we used to subtract in the case of prefix sums. In the prefix product we're going to divide it. So that's how the entire code is going to work. Let's try to code this up now. So initially we'll start with a container which is going to have just this value 1 in it, and every time we come encounter a value, if the value of nums or this value right here num is equal to 0, we know that we will have to again reinitialize list1 to 1 as we discussed, and if that's not the case, this list1 will get appended by, we take the value at the top -1, multiply that with whatever value we just encountered, which is num. So this is how we are forming our prefix product array, which is exactly this array. So now this is where we are adding the value. So now that is done. Now it comes the time to find the product tuple k. So again, something we need to make sure is, in this exact example that I took, this is our prefix product, right? We are doing our division in this. So in the case of 2, 6, 12, 36 and 40, this is what our array was. If the value of k is up till like the last 2, then we can manage. If it's last 2, it's manageable. If it's last 3, it's still manageable, because we are dividing this array by this, by a product up till this point divided by product up till this point, which is k -1 minus k, shifting the k -1 by that many times. But if the k values is greater than or equal to the length of this entire prefix array that we have, in that case we'll have to return a 0, because it's going to cancel out everything. So that's something that you need to make a note of as well, that if the value of k that they are asking is greater than or equal to the length of the prefix array that we have at a given moment, if that's the case, return a 0, and if not, then we can do the -1 divided by the -1 minus k operation that we saw. So just a small check here. If the value of k is greater than equal to the length of self.list1, in that case just return a 0, and if that's not the case, we can return the self.list1, the -1 index. We're gonna need to do a floor division, because a single division gives floating point value. We don't want that. We need to return an integer. So this is a floor division, self.list1 -1 minus k. Basically this means we are shifting the -1 index that we had at this point by k times, because the value of k could be 3, 4 like that. So we are shifting that by k times. This is what the minus k really means, and that's pretty much it. Now let's try to run this. As you can see, it's accepting our test cases. Let's submit this now. So as you can see, it's satisfying all the test cases, and it's a pretty efficient solution as well. And this is going to be a linear time, because what we are doing is simply with each passing value we are adding the values in the list, and then getting the product is a constant operation, because we are just doing a division using the prefix array that we have prefix product array that we are forming here. So this will be a linear time complexity. Alright, it's not showing me right now, but that's just what it is. Alright, thank you everyone. I'll see you in the next one. Like and subscribe. Bye.